reaction of metals with oxygen. Now all of us know that metals, they react with oxygen to produce metallic oxides. We have some examples. For example, the reaction of copper metal with oxygen to produce copper oxide. Similarly, for magnesium, the reaction of magnesium metal with oxygen to produce magnesium oxide. And let us have another example of calcium with oxygen to produce calcium oxide. Now all these oxides, these are oxides of metals, these are metallic oxides, and we have already discussed that metallic oxides, they are basic in nature. Metallic oxides are basic in nature, right? Why we call them as basic? Because metallic oxides, MO, metallic oxide, it reacts with acids to produce salt and water. All right, why we call metallic oxides as basic? Because they react with acids to produce salt and water. Now let us have another example of the reaction of aluminium with oxygen. Now aluminium reacts with oxygen to produce aluminium oxide. And what is the formula of aluminium oxide? How I will find the formula? Aluminium has valency of 3, while oxygen, it has valency of 2. So when you cross multiply, you get Al2O3. All right, so we know that the formula of aluminium oxide is Al2O3. We have already discussed all these in detail in class 9. All right, now let us balance this equation. I have 2 oxygen atoms on the left and I have 3 oxygen atoms on the right. Now if I put a 3 here, I get 6 oxygen atoms on the left, and if I put a 2 here, again 2 into 3, I get 6 oxygen atoms on the right as well. So oxygen becomes balanced like this. Let us balance aluminium. I have 1 aluminium on the left, and how many aluminiums do I have on the right? 2 into 2, 4. So I put a 4 here. Now this equation is balanced. Now aluminium oxide is again an oxide of a metal. It is again a metallic oxide. It is again a metallic oxide. So it should be basic in nature, because that is what we have done so far, that metallic oxides, they show basic character, right? But what is observed is that aluminium oxide, it reacts with acid to produce salt and water, right? Now when aluminium oxide is reacting with acid to produce salt and water, here it is behaving as basic. Also aluminium oxide reacts with bases. In the above reaction, I have shown the reaction of aluminium oxide with an acid. Now I am reacting it with a base. So it is reacting with a base also to produce salt and water. So when it is reacting with a base, we know that sodium hydroxide is a base. So when aluminium oxide is reacting with the base to produce salt and water, so how it is behaving over here is, it is behaving as an acid. All right, so aluminium oxide, it is an exception which is behaving both as acidic and basic. Such kind of substances, such kind of compounds which show both acidic and basic character are called as amphoteric. Amphoteric means it is behaving both as acidic and basic. So we call it as an amphoteric oxide. Now the above two equations, they are not balanced. So let us quickly balance them first. I have 2 aluminium atoms on the left and I have 1 aluminium atom on the right hand side. So I put a 2 here and make it equal to 2, make the number of aluminium atoms on the right as 2. Now in doing so, what I see is that now the number of chlorine atoms on the right hand side become 6. 2 into 3, 6. So I put a 6 here to get 6 chlorine atoms on the left hand side as well, right? Okay, now in doing this, I get 6 hydrogen atoms on the left, whereas on the right I have only 2 hydrogen atoms. So how do I make it as 6? I put a 3 here. Alright, now this equation is balanced. Similarly, balancing this equation, I have 2 aluminiums on the left, while on the right I have only 1 aluminium, so I put a 2 here. In doing this, I get 2 sodium atoms on the right, so I put a 2 here and make 2 sodium atoms on the left. You can check the rest of the things are balanced now. Alright, so aluminium oxide is an exception which is behaving both as basic and acidic, hence we call it as an amphoteric oxide. Now in this reaction, the salt formed is AlCl3, which you know is aluminium chloride. And you know why the formula is AlCl3. You can find that using the valency method, using the crisscross method. Now the name of this salt, which is formed in the second reaction of aluminium oxide with a base, is sodium aluminate. Sodium aluminate. This is something new for you. Let us see how we find the formula of this compound. Sodium and AlO2 minus is a polyatomic ion which is called as the aluminate ion. It is called as the aluminate ion. Okay, now using the crisscross method, I have the valency of sodium as 1 and the charge over this polyatomic ion is also 1. Since it is just minus, so it is minus 1. So when you cross multiply, you get the formula as NaAlO2. Alright, so this is sodium aluminate. So far we have seen the reaction of metals with oxygen, thus producing metallic oxides. So in all the reactions that we have just seen, we saw the formation of metallic oxides. Now what we are doing is we are reacting the metallic oxide with water. Reacting the metallic oxide with water. Alright, so when metallic oxides they react with water, they produce metallic hydroxides. Alright, when a metallic oxide it reacts with water, it produces metallic hydroxide. For example, let's have calcium oxide. When it reacts with water, it produces calcium hydroxide. You know why the formula of calcium hydroxide is CaOH whole twice using the valency method. The valency of calcium is 2 and the charge exhibited by hydroxide ion is 1, minus 1. So when you cross multiply, you get CaOH whole twice. Alright. Okay. So metallic oxide is reacting with water to produce metallic hydroxide. Calcium oxide, CaO is calcium oxide. Calcium oxide is reacting with water to produce calcium hydroxide. Alright. Let us see whether this equation is balanced or not. I have 1 calcium atom on the left, 1 calcium atom on the right. 1 and 2. 2 oxygens on the left and how many oxygens on the right? This 2 will be multiplied with both hydrogen and oxygen. So I have 2 oxygens on the right as well. 2 hydrogens on the left and 2 hydrogens on the right. So this equation is already balanced. Let us have another example of the reaction of magnesium oxide with water. Alright, so magnesium oxide, when it reacts with water, it is going to produce magnesium hydroxide. You know why the formula is of magnesium hydroxide is MgOH whole twice, just like I have discussed for calcium. Similarly, if I take sodium oxide, which is Na2O, why it is Na2O? Sodium valency 1, oxygen valency 2, right? So when you cross multiply, what do you get? Na2O. Alright, the formula of sodium oxide. So formula of sodium oxide is Na2O. When it reacts with water, sodium oxide on reacting with water will produce sodium hydroxide, NaOH. You know why the formula of sodium hydroxide is NaOH. You can find it out using this valency method that I have discussed. Alright, let us see whether this equation is balanced or not. I have 2 sodium atoms on the left, while on the right I have only 1. Okay, so equation is not balanced. I balance it by putting a 2 here. Now let us see for oxygen. I have 2 oxygens on the left and 2 oxygens on the right, because this 2 will be multiplied by each atom. Alright, so 2 oxygens on the right. Hydrogens, I have 2 on the left and 2 on the right. So now this equation is balanced. Let us have another example of potassium oxide. With water, it will produce potassium hydroxide, KOH. Again, let me balance this equation. Fine. So whenever metallic oxides, they react with water, they produce metallic hydroxides.